Let's take a look at rigging Blaze. So this character has been modeled by CauHi, and there's a link in the description below to go have a look at more of his artwork. And this is the character that we're gonna rig up using AdvancedSkeleton. If you want to look at the completed rig, you can do so by going to our website, click on the rigs section, and Blaze is the first demo rig on the top available for download here. Or even easier, if you have AdvancedSkeleton already installed, you can simply go to the demo section and hit check for online demo updates, and you should see that Blaze is now available for download. So just hit download, and once downloaded, you can just hit open. Now the model comes with textures, and it's all set up to be rendering in Arnold. So if you want to render out this guy, just go to your Arnold menu, add some lights, for example a sky dome, and hit render. And for close-ups, you can select the model and hit 3 on your keyboard to go to the smoothed version. And with Arnold, that's coming across in the renderer as well as a smooth renderer. Now on to the main purpose of this video, which is to show the steps taken to create this rig. So let's start with a blank new scene. And we will start out with the model. So this is the model as it was downloaded off ArtStation. This is quite normal when starting with models, that they will have certain non-default values, or maybe even construction history. In this case, you can see if you select the body, there's actually some translate values on here. So the first thing we're going to want to do is to clean up the model, and this is highly recommended. Now to clean the model, there is a function in AdvancedSkeleton to do that, and it's in the preparation step under model. So it says create a top level called geo. Yep, we will do that, and let's hit clean. We can now confirm that we select any of these objects that all have 0 transforms, and do hardware texturing and make sure that the textures are showing as they should. Okay, so for now this model is ready, and we're gonna save it out. And then to start the rig, we can just jump into the next section here and say new scene and reference in the model. Okay, we can see that when we use that reference button, it has not only reference in the model, but it has also assigned that model onto a layer called Hi, and it sets it to template. Next, there's a few ways we can go about it. One way is just the usual traditional way, which is just go into the body, import a fit skeleton template, and start fitting it. Another way that we will look at here is the auto placement that will try to automatically do the initial placement of the joints based on the geometry, and we'll use that this time. So define the objects as it says here. Say this is the skin. Then it asks what's all the object. That's going to be this one. Right eye. And in this case, both eyes is one object. So instead of just defining an object that's the right eye, we are going to choose the faces, that is the right eye, and the faces, that is the left eye. Okay, then we'll close the preparation section and open the body section. And here we will choose to import the standard biped. Now you'll see the standard biped comes in a standard 1/10 scale, whereas this model is in 1:1 scale. And we see that we now have these buttons here that says auto place, and first button says scale. And you can see right away we got roughly the right scale. And the next is that it will try to place the joints according to the model. So let's go ahead and hit auto place. Okay, so what happened here is it hit an error when we're trying to do the fingers. Now let's hit the auto place button one more time. That'll just clean out that attempt to auto place. And we'll have a closer look at these fingers, and we can see that the issue here going to be that the fact that these fingers are somewhat curled up to start out with. So what we can do to help the tool to place the finger joints is we'll just create a couple of temporary soft mods and just straighten out these fingers a bit. Now there's no need for this to be looking correct in any way. It just needs to have the fingers somewhat straightened out and separated from each other. So with those temporary soft mods in place, let's again try to hit auto place, and we'll say yes, we want to continue anyway. And there we go, that worked much better this time. Now once the auto place has been done, it's leaving us with these green and red handles, which essentially are handles that you can grab and slide up and down to help improve the placement. And you can see as it slides up and down, it stays within the center of the limb. So you basically have just the one axis you have to determine here. So for the elbow at the top, maybe we'll go to the top view, see the wireframe and shaded. And as we're moving this up and down, we can kind of see the exact edge loop here that it's been intended for the elbow. So that's where we'll place it. Likewise, for the wrist here, the knee joint, we're going to move a bit. And the finger joints are looking all right. That up, maybe up here, neck joint. All right, once we're happy with the trimming of the sliders, there's a couple of buttons here that says we can show the pole vector. And in some cases with auto place joints, you're going to end up with pole vector directions that are not ideal. Like in here, we can see that that knee is going to end up pointing inwards. And what we're going to do is just hit the button that says straighten the leg pole vector, and let's just also straighten the arm pole vector, and then hit delete, guys. Okay, next, before building the advanced skeleton, one more parameter in the fitting that I think is beneficial to adjust is the fatness of each joint, which we can do by turning on the geometry checkbox, which displays geometry for each of the joints. What we can do now, we can, for each of the joint, we can adjust the fatness. So let's just go ahead and do that and adjust that to roughly match the model. All right, that's looking a bit better. And this fatness for each joint will affect a couple of things. One is the default controller size is going to be more correct, and it'll also be used for some of the automatic skinning functions later on. So far so good. Next thing here to do is to run build advanced skeleton. And we can right away see that the size of the controllers are not too bad because we did the adjustment of the fat parameters. And then we're going to start looking at skinning this guy. Now, in Advanced Skeleton, there are several methods here for skinning. Now, for this guy, what we're going to use is the option number 2, which is a SkinCage. And I'll just turn off the geometry for now and hide the controllers. And let's go ahead and create a SkinCage. So the SkinCage is a procedurally generated geometry to match the structure of the skeleton. And it comes with what's called the skin curves, which essentially is curves around edges of the polygonal skin cage. So the idea is that we can take the skinning from this cage and transfer the weights to our geometry. So let's go ahead and select our geometry. At this point, I'm just going to select all the pieces and hit copy weights. And there we go. We now have weights for the character. So we can go out and test. Although these weights could already be a good starting point, they are far from perfect. But what we do now have here with the SkinCage is a setup for a workflow that allows us to improve the skinning, essentially by adjusting these curves. So the first step I like to run is the deformation width button. It's more explained here if you click on the help image. Second, I'd like to run the create growing locators. That creates 2 locators that based upon your geometry, you can place the growing locators, one in the middle and one off to the side. And if we now look at the SkinCage, as we hit the button that says adjust growing area, you'll see we get a much better distribution here. And then what we can do is start adjusting these curves to improve the deformation. So based upon that, we can start placing the curves. We're going to want to split out so that it looks something like this. And then the one red curve where the deformation starts is going to move upwards. And then the next one will be further downwards. So if we now look at the cage after this adjustments, you can see that we have, we're going to get quite different deformation. We can first just test the deformation on the SkinCage itself. Then we're going to go ahead and look at the geometry. First, we'll test how it looked, the deformation we were getting before we made the adjustments. So you can see that was quite unfortunate. Now we just select the geometry, hit copy weights. And then we try again, and you see we're starting to get much better deformation now because of the tweak that we made to these curves. Now it's important as you tweak more of these curves that you every now and then run this mirror function, that you mirror any changes done on the one side over to the other side. Now that is the base of SkinCage functionality. It's essentially this modeling of skin weights. Now there are some more advanced functions here that we are going to start looking at, and that is these things called SkinSliders. So to have a closer look and to understand the principle how these sliders work, let's go down and look at the knee. We'll select that middle skin curve and hit create slider. And you see that creates some joints, and these joints, as the knee rotates, are pushing outwards to help maintain volume. Okay, so far so good. Let's grab the red curve above it and create sliders here. And now as the knee rotates, you can see that these are also working on preserving volume, but these are sliding up and down as opposed to pushing outwards. And the one below it, if we now have all working in together, you can see that there's now a lot of motion of these joints moving around, all working together to help preserve the volume. And each joint has a slight attribute that says how much it will do its motion based upon the input controller. Okay, so I'll undo those. Before we create any of these sliders, we can turn on the one option that says include controller. So if we now create a slider, you'll see it's jumping around, and we can see what it's done. It's created a series of controllers where each of the slider joints are. And if we rotate the knee now, we can see we do have that slider function. So these joints are still doing the automatic sliding to preserve the volume. The way the sliding now works is that it's the controller that is sliding, and it's done with a driving system. So if we now go into the post section under driving systems and right click on edit, you can see that knee has now appeared as a driving system here. And since it's a driving system, it's kind of made it more easy and flexible for us to adjust the behavior of the sliding of these joints based upon the input, which is the rotation of the knee. So if we wanted to edit how much they slide, we can just say edit the knee, and the time slider has now become the input, which is actually the knee rotation. So if we wanted this to, for example, move much further out, all we have to do is just move this controller further out, and we have changed the programming of how it automatically gets driven. And next, what we'll do is we'll go ahead and create slider joints for all the major rotating joints. So let's go ahead and select the skin curves for that. And to make that selection easier, I'll just select that main controller on the rig. There's a joint visibility attribute. We can set to 0. And we can then choose to show only the skin curves. And we'll make sure to grab all the skin curves for the hips, for the ankle. Now for the ankle is not quite as complicated, so we're just grabbing those center green skin curves there. For the shoulder, elbow, and wrist. With all these selected, let's create slider joints, including controllers for all these skin curves. So we now have a bunch of these slider joints. And if we look at the rig, select the top node, turn off the joint visibility attribute, and turn on the partial vis attribute, we see that we do have all these slider joint controllers that are now configured so that they automatically move and driven by joints in order to preserve volume. But they also have the functionality of being additional controllers that the animator can grab if they want to do some fine tweaking. Now let's first go ahead and transfer the weighting onto our character, which we can do by hitting the copy weights button. And then we can start looking at some of the behavior of these sliding systems. So we can see we are getting much improved deformation over default skinning. However, well, we can tweak this even further to have things such as making this part of the arm collide with this part of the arm as the rotation gets closer here. And the way to do that, it would be to edit the driving system. So to edit the driving system, which is driving these sliders when the elbow is bent, we go to the driving system section. So we can right click on this button and choose edit. We're looking for elbow and the rotation. So what we can do is move these three guys around a bit. So at this point, will they start kind of pushing away from each other so that we get this effect where essentially it looks like they, at this point where you start to get contact, they start pushing each other around. And once we're happy with the way this animation looks, we'll just hit apply. And again, the driving system then turns that animation into a driving system. So now there's no animation on the timeline, but the animation is based upon this rotation. So you can see that rotating the elbow now gives a little bit of that illusion that these are pushing and colliding with each other at a certain angle. Now, another thing that we will use on our character here to improve on the deformations is we'll go ahead and use the delta mush deformer. So you can see that if we rotate here, we're getting a lot of these crunched polygons that are looking not so nice, especially under the arm here. Now, this can be improved by going in and manually doing the weighting. That is a bit tedious, takes a bit of time, but can give quite good results. We're going to do a lazy option here that also gives good result, and that is the delta mush deformer. So we'll open this section called delta mush. We will not do the hardening weights. That works on fairly low poly characters better, but we will apply delta mush. And we see that we now rotate this shoulder. That's looking a lot better. And as normally, we can see the effect of the delta mush before and after by just clicking on the deformer and sliding that envelope attribute up and down. And we can see that before it was looking not so nice, but with the envelope set to 1, the results are looking much better. Another thing we're going to look at now is this scapula. You see that when we lift up the scapula, there is not much going on in this part of the model. Likewise on the back, there's just not much going on with the shoulder blade part here. Now to address this, we will use another function called the CustomControllers. So let's open the CustomControllers section, and we'll create controllers for the front and the back to move that area. And we'll use DrivingSystem to automatically drive the controllers moving when the Scapula controller is rotated. So we'll start on the back. And the way this works is you define the area by a soft mod. Just click where you want the area to be. So maybe a little bit bigger. For example, this will be the shoulder blade area here. And we'll hit create skin control. And the name, we can use that default name, that's fine. But the parent, we're going to make sure that is set to chest. Okay. So we now have a new controller here. And we can see that that kind of moves this shoulder blade area. And we got one for the other side. Now, what we're going to want to set is that when this moves up, this automatically gets driven to move up along with it. So the way we're going to do that is we just first set what's going to be the driver. So this rotate up, and let's use an exact value. Let's say minus 35. As this goes 35 degrees up, this guy is going to move up, and yeah, why not rotate a bit with it as well, like this. Then we're gonna want to go to the driving systems section and create driving system. Now, if we were to do this as is, that's not correct. We'll do it just to show you. If I hit OK, create, you see we now have a driving system with an attribute, and it's moving both these together. That's not what we wanted. We want this to be automatically be driven by this, not a new driving system that drives the both. So I'll hit undo, and we'll hit create driving system again. This time I'll show you that the right thing we're going to want to do here is, the option's not available because we didn't select it. We're going to make sure we select the one we want to drive, hit create driving system, and you see we now have an option that says drive from selected object. So we want to drive from that. Yep. It's noticed that the rotation Y is the one that rotated. We're going to mirror and Q rotation, which essentially is quaternion rotations instead of Euler rotation, which, yeah, simply put, it just helps you avoid with some of the issues of Euler rotation values not being reliable, accurate drivers. So this is creating the extracting quaternion rotation values as the driver, which will usually give better results. We'll hit OK. Now, we did not get any new controller created, but we'll see that if we now rotate this guy, indeed, it does automatically drive this guy. This is still a controller that's free to move around and animate, but it is automatically driven by this going up. Let's do that same for the front. So we'll see the front. By default, not much going on here. Again, go to custom control, create a soft mod, say, yep, that's going to be our area, create a skin control, and make sure that parent is going to be the chest. Hit OK. We'll test our controller. Yep, that seems to be doing the right thing, and we're going to want it to be driven by this thing again. So what we can do is instead of create driving system again, we can just say we want to edit the current driving system and add this to be influenced as well. So we can go edit, scapula, rotate. Now, by default, you see that that's not showing us the new controller because hit cancel. because this option box here that says show only affected. So by default, when you edit the driving system, it only shows you the ones that are already affected. If you want to add new ones, then you want to turn off this and now say edit Scapula with driving system. And we now see anything. So be careful what you move now. Anything you grab and move here will be now driven. Again, as we're editing the driving system, the time slider has become the input. So you can see we can slide the time, and this time to -35 because it was -35 degrees as the driver. We grab this controller and we'll just go ahead and move and rotate it a bit into place here. And okay, hit apply. It's detected that you modified this control, and it's confirming, do you want to add? Do you want to edit the driving system to also include these attributes from that controller? Okay, that's what we want. And if we now rotate the scapula, you see it's pulling with it. That's controller as a driven. So that's looking better, the front and the back, and the left and the right. And so far, so good. Next, we're going to move on to the face setup. For now, we are done with the body, so there's no point of carrying this SkinCage along with us anymore. That's just making the scene slower, and we're not using it. So we'll go ahead and delete that, and the right way to do that is to go into the SkinCage section and hit delete. Okay, face setup. Now, for the face setup, I recommend not having the delta mesh. So you select the geometry, and then you just click to highlight that deformer and go edit, delete node. And you can see the delta mesh is now removed. Okay, first step, mask. Let's go to the side view to select the mask. Go to face and use the lasso tool. And let's go ahead and do something like this. And say that's our mask. And next face, that's going to be this guy. All head, so everything affected by the face setup. Let's go to the outliner, make sure we get them all. The main body, the eyes, the eyebrow, the teeth, and the bandana, which was hidden. So these will be all head. And yes, it will add a skin cluster onto it. And then we're going to do right eye, left eye. And again, in this model in particular, the right and left eye are not individual objects. It's actually one object, but that's fine. Then we just got to make sure we select the faces that are going to be for the right eye and the faces that are going to be for the left eye. Upper teeth. Now for this model, all the teeth and the tongue is all one object. So what we want to do is to grab the polyfaces that represents the upper teeth. So I'll go to faces, grab kind of roughly the right area like this, and then we'll just hit grow selection and hit the G to repeat, and that should give us the right selection. So these are going to be the upper teeth. So that's going to be all the lower teeth. Tongue, this, G. Tongue. And then the eyebrow. This object is the eyebrow. And there's no object for eyelash. Extras. Let's do the hair and the bandana as extras. Okay, we want the rig type to be joint. Blah, 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 all the default. The rest is going to be all default. And then comes the fitting. Let's start with eyeball. Just hit the button. Now it's going to be pretty much in the right position to begin with, because we did the body auto fitting. So that's in the right position there. If it's not, you move it to be in the center of the eyeball. Now what we do want here is we'll just tweak the rotation a bit, because you can see that by default this guy has his eyes going a little bit outwards and downwards. So we'll rotate it a tiny bit so that it's also oriented to aim, matching to the model. Eyelid outer, yeah, that's going to be our outer eyelid. Eyelid main is essentially the edge loop where you're going to make contact between the upper and lower. Eyelid inner, we can see it needs to be on the inside of the eyelid, which can be a bit hard to get to. So there's an assist button that peels open the eyelid that lets us fairly easily get that edge loop that's inside. Eyelid inner. Once we complete eyelid inner, we get this red surface that represents the eyelid. And good idea is sometimes you can just investigate and double check that you got what you expect, which is you got this object that wraps around from the outside to the inside of the eyelid. So that's what we got. Good. Next, lip. So let's go lip outer, lip main, and again lip inners on the inside. We'll use the assist to peel this open. Grab one of these inside loops, hit lip inner. Once created, just hide the models, inspect that this fit lip object is an object that wraps around the lip, looking good. Okay, eyebrow inner. So here we're going to make sure we do not pick any object on this attached piece of geometry. We're going to make sure we pick a vertex on the main mesh. That's important. So let's pick the one that's closest to the leading edge here. We'll go with this guy. Eyebrow inner. The next is eyebrow outer, which is at the other end of the eyebrow. So we'll pick that vertex. Then eyebrow center. Now watch out with this one. There's a common mistake is to think that that's going to be center between the outer and inner and pick one of these. That's not correct. If you look at the help image, it's a center, meaning the middle of the model. So the next eyebrow center is going to be this guy here. Forehead. So we're going to need to hide that bandana for a bit. Let's hide the hair too. For the forehead, you can see it says select 3 vertices. The help image shows that, and it shows you that you can kind of imagine a line from the eyelid corners inwards and outwards. So we're going to want to pick a point around about here, and we're going to imagine the one from the corner. So if you imagine this edge from the corner of the eye towards the center of the model, so this edge is going to be at the center of the model at this point. That's going to be our first vertex. Another one is going to be from this corner. We're going to just traverse out towards, let's say, about here. And then we can kind of traverse along this edge up till we get to the center again, which is going to be here. So we got these 3 vertices selected, and let's hit the button that says forehead. And yep, that's fine. Jaw pivot. Okay. Vertex selection, select one vertex, make a jaw pivot. And put the jaw corner. Got the jaw line. The jaw itself is going to be right at the tip of the jaw here. Yep, fine. We will replace the jaw from the body setup. The jaw crease will be about there. Throat. We're going to want to go right under where jaw comes in and meets the throat. The next one is cheek. For cheek is where the, essentially, if you imagine inflating your cheeks, you can imagine where is the highlight point where the cheeks are the most inflated. So for this guy, I'm going to guess that's the point where his cheeks will inflate. The cheekbone is up around about here. The smile bulge, essentially, if we start smiling, there's going to be this fold that starts folding up. So the point of that fold going to be there. Likewise, that frown bulge, I'm going to pick along the same edge loop, but on the lower side for frowning. The next one is nose. Then is the nose under. here. Nose corner right in the corner. Nose side is, imagine, from the corner going upwards, halfway up to the eye corners. There's going to be a point there for nose side. Nose bridge be here. Nostril, we'll pick this guy, and that's it for the main face fitting. Now let's go ahead and do some of the optionals as well. So we got tongue as an option here. I'll hide this. Let's confirm that yes, we want to have tongue. We'll create that. You can see that that's making these 5 locators with a curve in between them. So what we're going to want is the first locator to be in the base of the tongue, and then each locator along the tongue until the tip. And you can use the arrow key on the keyboard to quickly pick between each. And in terms of spacing between them, it'd be good to have that matching the way you want the animation control. So essentially, the first space is going to be the largest one, and then progressively closer and closer, so you get more fine control towards the tip of the tongue. Okay. Optional pupils. Yeah, we will have pupil control for this guy, so we can define both iris and pupil. Let's go ahead and select the edge loop corresponding to the iris and the edge loop corresponding to the pupil. Up, mid, low. See the help image desk gives us some funky bendy face cartoon type controllers, which are kind of cool. So we'll have that. We'll hit create up, mid, low. By default, they're gonna be placed in relation to the mouth and the eye. So the default placement is usually just fine. That's it. Fitting complete. Time to start building. Now here, I absolutely highly recommend saving a version of your file. I'm going to save this out. I'm just going to call this before face build. Now I have that as a file saved in case of errors and I need to go back. So to build a face setup, there are 2 options. You can just hit the button that says build face setup and wait for the entire process to finish, or you can do the step-by-step, which can be a good idea, and it can sometimes give better results as it allows for individual tweaking along each step. So let's do that. Let's do the steps, starting at the beginning. Step 1, prep. Next, control box, eyeball. Now, starting as of these steps, I like to actually test the result for each one. So we have eyeballs and we have some controllers. So you can grab these controllers and move them. Make sure that the eyeballs are rotating, and you can test the attributes. So we have control that controls the iris size and the pupil size. All seems to be working. Good. Next, eyelid. And I can test that rotating the eyes now includes the eyelids following. This is called the fleshy eyes. So working. Next, eye blink. So this is the blink, which is essentially going to become a driving system, and you can test the effects here on the time slider as it says here. It says, if you read the tiny print, it says scrub time slider to check, with a little help image that explains that you can check now your animation on the time slider and you can adjust it. So if you were not happy with the way the blink works, you can actually edit this animation, which then essentially becomes the blink attribute. And instead of just jumping to the next step, you can complete this step by right-clicking where it says scrub time slider and say, okay, finish the step. So let's just finish the blink step and created those blink attributes here. So we can test that animation has now become driving system and is now these attributes. All right, next, eye wide. So here's an opportunity for us to edit the driving system and during the build. This might be a bit too wide for the upper eyebrow here, so we'll just make sure we go all the way to the end of the animation. I want to reduce this value a bit because I thought it was just a little bit too much on the upper, and maybe we'll increase a bit on the lower. And we'll slide to the time slider, make sure that's what we want. Yep, I like that one. We can then right click and say finish so that we get the attribute. We can test it here for white. Yep. All right. Lip. And we can then test the lip by moving these controllers. Now, it might be a bit hard to imagine the end result because currently just the lips are weighted and not outside the lip. But with that in mind, you can test the behavior that the controllers are indeed moving the lips. And that's all looking fine. Now, the effect that these lips are having on the outside lip area is going to be the next step. That's lip fall off. So we'll hit that. And here, it's also possible to see that we have some test animation here that's showing us how that fall off works. Fine. That's an appropriate amount of lip fall off there. So I'll be happy with that. And we'll go to the next step, FaceCage. So that's building the polygonal cage representation of the face. And then cage to skin. And there is an option here for how much smoothing to apply after transferring the skin. We'll keep the default, however, and move on to the next eyebrow. And I can test and confirm that the eyebrows are working. Squint. Again, this is driving system, so it says you can check the time slider. And you can see that if you select some of these controllers, there are animation here, and you see that essentially the squint is achieved by applying scale and translation to some of these controllers. And you could, if you wanted, edit which controllers are affected and by how much. And once you have it, you can hit OK finished, or you can just jump to the next step. Some mild pull. If you want to make changes, you make these changes at frame 30. Okay, let's say we want this for the smile. And again, we can say OK finish. And to test it, you can kind of move these controllers up towards the corner. Next, frown pull. It's looking fine. Next, cheek. We can see how the cheeks will inflate with these controllers. If you wanted that to be more, say you wanted them to blow up more, you can just increase the scale at frame 30. You can move them out, increase the scale if you want it. As such, for example. Next, cheek razor. Again, this is animation, driving system animation. Jaw weighting. And that's fine. Jaw open. Next, lip up. It's fine. Lip down. Lip side. Snarl. Tongue regions. Eye aim. And the up, mid, low, which gives us these controllers that are kind of cartoon, squashy, stretchy, allows you to distort the entirety of the face based upon three main regions, the up, mid, and the low. And then we got phonemes, emotions, and finish. Then we have a complete face setup. I'll go ahead and just unhide his hair, and we can test the face controllers here. And at this point, we want to reapply that delta mush, and we will do it here from the face section, because if you apply from here, it has automatically the correct delta mush weighting, which if you check in the deform menu and the paint weights for delta mush, you can see that the weight has been painted is such that the delta mush will not apply right in the center of the lips and the eyelids, because if it did, it would not have a proper contact when blinking or using the sticky lips functions. And at this point, we have a completed rig both for the body and the face. And just for testing, what we can do is open the selector or pick a tool. Under the anim menu, there's a function here called mocap library. So we can use this and just grab any of the motion capture clips here and hit apply. And we can see that this indeed seems to be working. We're going to remove that and test the face with the range of motion clip. And that seems to be working as well. So that's it for this time. I hope you have enjoyed this video, and I'll see you next time.